So this video is on conditional probability. For events A and B, we use notation A, then like a straight line B to represent A given that B has occurred. And our formula is the probability of A given B equals the probability of A and B divided by the probability of B. So we've just got one example to show this. In this example, we've got in a town, 25% of residents own a cat, 55% own a dog, and 30% do not own either. And we want to draw a Venn diagram. So I've already drawn my rectangle and circles there, and we're going to have cats and dogs. And now from the information we're given, we know the outside is 30% because 30% do not own either. And you could write that as 30% or 0.3, it is your choice. I think I'll actually write it as 0.3 because with calculations it will be easy to work with. Now to fill in the rest of the Venn diagram, we have to be aware that 25% that own cats is a whole circle of cats, which includes intersections. So we have to figure out a way of working out what the intersection is to work out how many only own a cat. Now to do this, if we look at this Venn diagram, if the outside is 0.3, that means the circle section must be 0.7. So the probability of C or D, cats or dogs, which is all the circle parts, will equal to 0.7. And I'll just put here that would be 1 minus 0.3. And now from here, because we know that, we can use our addition law from the last video, which was C or D equals the probability of C plus the probability of D minus the probability of C and D. Because we know 3 of these, so we can work out the intersection. So the first part, C or D, we know is 0.7. Probability of C is 0.25, 25%. D is 0.55 because it's 55%, and then we will be minusing the intersection. Now from here we can just do some working out. So we'll have 0.7 equals 0.25 plus 0.55, which is 0.8. And then from there we can see that the probability of C and D would be equal to 0.1. So from there we can put that into our Venn diagram. So we'll have 0.1 in the intersection, which then means cats will be 0.25 minus 0.1, so 0.15. So that the whole cat circle now adds up to 0.25. And dogs will be 0.45, so that whole circle adds up to 0.55, which is 55%. Now B, we want to find the probability that a randomly selected resident, firstly, owns a cat given that they own a dog. So we want the probability that they own a cat given, which is a straight line, they own a dog. And the formula for this, if you go back up to your notes from before, it's the probability of C and D divided by the probability of the given, which is D. So the probability of C and D we've just worked out in part A, which was 0.1, divided by the probability of D, which is 0.55. And that will simplify down to 2 on 11. And then part 2, we want does not own a dog, given that they own a cat. So we want the probability of do not own a dog, which is a complement of dog, so D dash, given they own a cat, so given they are C. So now we want the probability of they do not own a dog and they own a cat divided by the probability of the given, which is the cat. So we now actually have to work out that the probability of they do not own a dog and they own a cat. So we can just go to our Venn diagram for this. So we want they do not own a dog and they have to own a cat, which means we are looking at the cats only. So this bit I'm just shading here, which means that will be 0.15 divided by the probability of cats, which was 0.25. Simplify that and you will get a 3 out of 5.